Hi, this is a quick video for students that are struggling with common denominators. So if you feel comfortable with common denominators, you do not have to watch this video. But if you've tried the homework and it's a struggle, let's try to do a little bit more studying on common denominators. So the first question I have is when to use a common denominator. Many students are confused about when you need to use a common denominator. You only need common denominators when you add and subtract fractions. Okay, so only when you add and subtract. You do not need it when you multiply and divide. So for example, if you have 2/3 plus 1/5, you need a common denominator. If you have 2/3 times 1/5, you do not need a common denominator. Now just to rehash, what do you do when you do have 2/3 times 1/5? Remember the rule, you multiply numerator times numerator. 2 times 1 would give you 2. And you multiply denominator times denominator. 3 times 5 is 15. Sometimes you have to reduce that to lowest terms. But you can't do that here. You can't just say 2 plus 1 is 3 and 3 plus 5 is 8. That's not allowed at all. You must have a common denominator. Okay, so when do you need it? When you add and subtract only, not when you multiply and divide fractions. Now here's the really big question, why to use a common denominator? So we know when to use, when you add and subtract fractions, no other reason. But why to use common denominators? Why in the world would you need such a thing? And one of my favorite problems to talk about, and you may even remember this from way back when in elementary school when you were first introduced to fractions, and even when I've taught this to adults in the classroom, I've used this example with real Hershey bars. I'm sorry you're online and you don't have your own. Stop the video, go buy yourself a Hershey bar or two and come back. But anyway, so why do you need a common denominator? So let me give you an example. Let's say I want you to add 1/2 plus 1/4. Okay, now we already know that's not 2 when I add the tops over 6 if I add the denominators. That's not allowed. But I want you to see why that doesn't work. So if I want to shade in 1/2 of this Hershey bar, okay, so look, it's divided into all these little squares like a real Hershey bar is, and I want to shade in 1/2 of that. So you know 1/2 would be divided right down the middle. So notice that's this square, I know this gets old, me shading them in, but that makes sure you're really with me and you're following along what I'm doing. You agree that's 1/2 of that Hershey bar plus 1/4 of the Hershey bar. Now, what is 1/4 of a Hershey bar? So I would divide this Hershey bar up into 4 equal pieces. Well, notice it's actually in 4 equal columns. So 1/4 of the Hershey bar would look like this, right? Now, I can't just say that's 2/5. Imagine dividing this up into fifths. That doesn't even make sense. So the reasonable way to add it together is if you add the same size. So if I had to add halves plus fourths together, I'm not even talking about the same size pieces. So I can't just do that. But one thing we can do, if you'll notice this, is talk about how many pieces we have shaded in. So a Hershey bar has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, right? Well, how many pieces do I have shaded in? I have 6 out of 12 of those pieces shaded in, all right? And the second Hershey bar, because I'm adding these two fractions together, I have 1, 2, 3 out of 12 pieces shaded in. Now this I can add together because I'm talking about the same size pieces. So I can add together 6 plus 3 is 9 of these 12th sized pieces. Okay, so 9/12 of the Hershey bar. Now what does 9/12 of the Hershey bar look like? Well, as you can imagine, if I moved these red pieces down here, then 9/12, I'm shading in my total green. Right there, that's 9/12 of the Hershey bar. But you know what? That's also 3/4 of the Hershey bar. If I divided, you notice these both divide by 3. and that gives me 3/4. Now, you're already used to doing that. You're already used to simplifying fractions lowest terms, but I wanted you to see it in action. Okay, so Hershey bars are a great way to describe fractions, but you can't add different sized fractions together. It's like adding apples to oranges. It just doesn't even make sense. And so you want your pieces to be the same size that you're adding or subtracting. Okay, I hope that makes sense. Just to make sure it hits home a little better, let's do another example. Now, another Hershey bar example. Again, this is just so you have a visual of what's going on. Don't worry, I'm not going to change every problem to Hershey bars. I can't, right? Because 2/5 is a little bit of a struggle when you have 12 pieces of a Hershey bar. But what if I wanted you to find 2/6 of this Hershey bar? So first of all, I'd have to divide this thing into 6, right? Can I do that? What's 1/6 of a Hershey bar? Well, there's 12 pieces, right? So if I divided this into 6, then I would need 2 pieces for each of the 6. So 2/6 would be 4 pieces. Does that make sense? 1/6 would be, so how many are there? 6. So that's 1, 2, 3, 4, 5, 6. 2 pieces would be a 6th. So 2/6 would be 4 pieces. So that's 2/6 of the Hershey bar. Plus 3/4 of the Hershey bar, that might be a little bit easier to comprehend. If I divide this Hershey bar up into 4ths, right, that's a 4th, that's a 4th, that's a 4th. There's 4 equal pieces, and I need 3 of those. So I shade that in. I need 3 of those 4ths, and there we go. Now, once again, we could do like we did a minute ago. If I add all that together, then how many of these little squares do I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Whoa, wait a minute. That means I have all of a Hershey bar. Look at that. All of a Hershey bar plus an extra square that I didn't have room to shade in. So that's my 13 pieces. Now, we just did it just counting squares, did we not? We just counted squares. But let's think about this in terms of a common denominator, okay? Now, notice I said 12ths. That worked. How many 12ths is my blue Hershey bar, my original Hershey bar? Well, there's 1, 2, 3, 4 of those shaded, so that's 4 12ths. And then I'm adding that to how many 12ths is this? Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. And notice 4 plus 9 gives me 13 12ths. Now, you learned in a different section that whenever the top number, the numerator, is bigger than the bottom number, the denominator, that can be written as a mixed fraction, right? So 12, we did it this way, divides into 13 one time. And there's 1 left over, so that's 1 and 1/12. And look, that's exactly what we've got shaded. 1 whole Hershey bar is shaded in, plus this extra piece, 1 and 1/12. Okay? Now, again, we can't do this with Hershey bars every time. Here's what we're really going to do. We need to figure out what number does both 6 and 4 divide evenly into. Okay? Well, we know 6 divides into 12, all right, and we know 4 divides into 12. Now, quickly we know that because this is broken up into 12ths, right? But what you're really doing is you're asking yourself, what do you multiply this 6 by to make it a 12? Well, times 2. Now, the thing is, if you multiply the bottom times 2, you must multiply the numerator times 2 as well, so that gives you 4 12ths, and that's that 4 12ths we have over there. Now, what did we multiply 4 times to get a 12? Well, 4 times 3 equals 12, right? So multiply 3 on the bottom and 3 on top, and 3 times 3 is 9. And then finally, 4 plus 9 gives me the 13 12ths. Now, let's throw out the candy bars. I just wanted you to have a visual of what's going on. Now, let's just work with some problems. We'll build up small, easier to harder. And I'll grab a couple of problems directly out of the homework so you can follow what they're saying. Okay, so our first problem where we have to subtract fractions. Now, I always want to remind you, every time you see a problem with fractions, ask yourself first, what's the operation? Am I adding, subtracting? Am I multiplying? Am I dividing? Am I just reducing? Well, you're subtracting. Remember, there's only 2 times you need to find a common denominator, when you're adding or when you're subtracting. And notice we do not have a common denominator. Clearly, 5 and 2 are not the same number. So here's what I encourage you to do. I encourage you to rewrite the problem. Of course, if you're working on the computer, that's required, with some space around it. Notice that looks like it's just way too far apart right here. Okay? Now, we need to rewrite this problem with some space. Now, the next issue is I need to find a common denominator. Now, there's going to be a problem coming up where I break 5 and 2 down into prime factorization. But listen, 5 is prime. If you think about the numbers that multiply to give you 5, it's only 5 times 1. 2 is also a prime number. It won't break down anymore. So whenever that's the case, you just multiply these denominators together. 5 times 2 is 10. That's your common denominator. Okay, it's just 10. So how do I turn this 5 into a 10? Well, I multiply it by 2. If I multiply by, I love that 2. If I multiply by 2 in the denominator, I multiply by 2 in the numerator as well. Now, in the numerator, that's going to give me 2 times 2 is 4, and 2 times 5 is 10. Now, I'm going to do the same thing over here, but 2 times 2, 2 is not going to work, right? What do I multiply a 2 by to make it a 10? Well, we know that that's going to be a 5. Now, I know you just noticed that really I'm just multiplying this one times that one and that one times that one. Okay? And that will work. That gives me 5 on the top and 10 on the bottom. Now, these are the same size pieces of candy bar. That's what we got. It's the same size. 4 tenths means 4 of something that's a tenth size, and 5 tenths means 5 of something that's also a tenth size. And when I subtract 4 minus 5, remember, now your integers, right? If I have 4 and I subtract 5, I'm subtracting a number that's bigger than what I started with. That's going to give me a -1, and I keep the tenths. Another way to think about that is you change your subtraction to addition, and you change the sign of the next number, and you add. We know 4 plus a -5. Whenever they're opposite signs, the rule is to subtract the numbers. 5 minus 4 is 1, but since the bigger of the two is negative, my answer is negative. Okay? Now, I'm going to show you a different way to do that in a minute, but not yet. This is, to me, the best way to handle it. Okay? All right, here we go. So I have 3/8. I'm subtracting 4/9. First question is, do I need a common denominator? Well, I'm subtracting, so yes, I do. Do I have one? No. 8 and 9 are different numbers. So I rewrite the problem once again with plenty of space to do some calculations. Now I'm going to show you something. I want to break 8 down into prime factorization. Okay, now 8 breaks down into, just give me two numbers that multiply to give you 8. And 2 times 4 does that, right? And I can even break 4 down again into 2 times 2. So 8, look, I circle when I get to the end of the branch, is 2 times 2 times 2. And you could check it. 2 times 2 is 4, 4 times 2 is 8. Okay, so 8's broken down. At 9 over here, I can break that down into 3 times 3. 3 doesn't break down anymore because it's a prime number. Now, what I want you to get used to looking at is, do these denominators have anything in common? These are all 2's. These are all 3's. There's nothing in common there. Therefore, I'm just supposed to multiply 8 times 9 together to get the common denominator. Okay, easy enough. Then I'm supposed to multiply this 8 times 9. If I do it in the denominator, I do it in the numerator. I'm supposed to multiply this 9 times 8. Denominator, numerator. And then I say 9 times 3 is 27. Over 8 times 9 is 72. Minus 4 times 8 is 32. Over 8 times 9 is 72. All right. Then once again, we have 27 minus 32. Well, 27 is smaller than 32, so I need to use my properties of integer, change the subtraction to addition, change the sign of the next number. I subtract these two numbers because they're opposite signs. 32 minus 27 is 5. But the bigger of the two numbers is negative, and I keep the 72. I should always check to see if I can reduce that fraction. 5 and 72 don't have any common factors, so I'm finished with that problem. Okay, next example. Once again, let's recopy it with some space. As I'm recopying, the big question is, do I even need a common denominator? And you say yes, because you're adding fractions that don't have denominators that match. Anytime you add or subtract, you definitely need a common denominator. Now, you might look at this and see what the common denominator is, but in case you don't, again, let's break down these numbers. So look, 16, I could write 16 as 4 times 4, right? And then 4 breaks down into 2 times 2, and so does this 4. And I like to circle my numbers at the end. 2 won't break down anymore. Well, look at this 4. It breaks down into 2 times 2. Now, here's the fun part. If they have any factors that match, okay, so this one matches with this one, right? And this one matches with this one, okay? Then you can ignore what matches, and you have to multiply the other fraction by what is missing, okay? So this one's not missing anything. Do you see what I mean? This one has 2 times 2 times 2 times 2. But this one, to make it match, I need to multiply it times another 2 times another 2. See, that way all the list of numbers matches. So I need to multiply this fraction over here by 2 times 2 is 4 on top and the bottom. And see if that doesn't give us a common denominator. So 5 over 16, notice I didn't multiply it by anything, it stays. Plus, over here, 4 times 4 is 16 in the denominator. 7 times 4 is 28 in the numerator. You keep that common denominator of 16, and I add 5 plus 28 together. It gives me 33 over 16. Now here's the question, will 33 and 16 simplify to lowest terms or reduce? Well, 33 and 16 don't have any numbers that divide in both of them. 33 can be divided by 3 and 11, but 16 can be divided by 2, 4, 8. Nothing in common there, so we are finished with that problem. Now let's try this again. So I'm adding 17 over 8 plus 10 over 12. I'm adding, so I need a common denominator. 8 and 12 are not the same number, therefore I definitely need a common denominator. So put some space between your fractions, and let's break 8 down. Okay, so we know 8 we can rewrite as 4 times 2, right? And then 4 we can rewrite as 2 times 2, but this 2 would be just 2 times 1, which doesn't get you anywhere. So that's the end of the line there. 2 times 2 times 2. How about 12? 12 can break down into 4 times 3. 4 can break down into 2 times 2. 3 won't break down anymore. Okay, so I circle my numbers at the end of the line. Remember, what we're supposed to do is find out what matches. Okay, so they both have a 2 times 2. You see that? Now what I'm supposed to do is multiply the other one by what it's missing. So notice over here, this guy over here doesn't have that 2 right there. So I'm going to multiply by that extra 2, because I need that extra 2 over here so they match. So what do? I put a 2 over 2. Now what's this one missing? Well, that doesn't have that 3 right there. Okay, so what do? I multiply my list over here by that extra 3, so now it's a 3 times 2 times 2. Notice it's the same numbers in the bottom, so 3 over 3. And now I actually do the work, 3 times 17, so you might have to do some scratch work over to the side or use your calculator. You know, 3 times 7 is 21, carry the 2, so that's going to be 3 times 1 is 3 is 51. So I have 51 over 3 times 8, which is 24. Plus, now over here, 12 times 2 is 24 in the bottom. and 10 times 2 is 20 on top. And notice I have a common denominator now, so that crazy trick of making numbers smaller and breaking them down and seeing what you're missing gets you what you need. So 51 plus 20 is 71 over 24. Now, as long as these two numbers, 71 and 24, don't have any common factors, we are finished with this problem. And you have to think about things that divide possibly into 71. You know, check 2 doesn't, right? Check 3, check 5, you know, check them all. To me, it looks like there are no common factors. When I think about 24, numbers that go into 24 are 2, 3, 4, 6, 8, 12, 24, and none of those numbers go into 71. So that's how I know we're finished. Now we're getting there. I have a few more problems I want to show you. So common denominators, notice I have written up there a different way. Now I encourage the way we have already done these problems. I really do. Like, for example, right here where we break the 8 down into 4 times 2, and then it turns into 2 times 2 times 2, and 12 into 2 times 2 times 3, and you multiply by what you're missing. I really, really encourage that because it will help you with other types of problems that you have through any algebra course. But if you're struggling, really struggling, and you just need a way out, I want to show you something. You can do this trick where you multiply 3 times 9, okay, and that gives you 27, and you put that on top. And then you multiply 8 times 4, and that gives you 32, and you put that on top. And then you multiply 8 times 9 on the bottom, and that gives you 72 and 72, and whatever operation you put in the middle. That is a trick to get you by, okay? But the problem is the numbers get really big sometimes. So in this case, it works out exactly like the problem we did earlier when we worked it out. 27 minus 32 gives you -5, and you keep the 72, and that does not reduce. Now, I'm going to show you again. Now, remember, we've already done both of these problems. Let me back up and show you the 3/8 minus 4/9. There it is. So 3/8 minus 4/9, we got -5 over 72. That's exactly what we got here. We've already done this problem as well. Okay, so remind me, what did I do? I crossed this way, and that goes in the second. So it's like you're doing an arrow. You're crossing that way, and that goes there. You're crossing that way. 12 times 17. Now, I don't even know what that is. I'm going to type it in my calculator, and I get 204. Now, you remember what goes in the denominator? Those two multiplied together, and we know that 8 times 12 is 96. So 96 goes there and there. And whatever your problem is, there you go. Now, the next step is the reason I don't encourage this method unless you're absolutely desperate. 204 plus 80 is 284 over the common 96. That reduces. And see, when we did it before, let me show you the answer we got before. We got, let me find it. I'm sorry. There it is. Okay, 17 over 8 plus 10 over 12, we got 71 over 24. You would have to reduce this to get the 71 over 24. So you would need to see that that 96 divides by 4 and that 284 divides by 4. So your numbers get really, really big, especially if you're doing problems that have really, really large numbers. So my encouragement to you is to try it the other way. But if you're desperate, remember what you do. You cross this way, and you put that number in the top, multiply that way, put that number in the top, and then multiply the bottom, and that's what goes in the denominator. So here I have a problem directly out of the homework. And this is a prime example of where that quick trick that I showed you, where you cross a numerator and a denominator and a numerator and denominator, won't work because we're not adding or subtracting any values. They just want you to find a common denominator with 385 as the denominator. So here's what I suggest, very similar to the earlier problems we did. Write down your fractions with some space in between. Okay, and then you're going to break down each of your fractions. Well, here's the fact. 5 is 5 times 1. It's a prime number. It doesn't break down anymore. Okay, same thing with 7. 7 is 7 times 1. There's no other way to multiply to get 7 or even 11. But now our common denominator is going to be 385. So let's break 385, a really big number, down. Okay, and we're going to see what we're missing. All right, so here we go. 385. What goes into 385? Well, because it ends in a 5, and every number that ends in a 5 or a 0, we know breaks down more. So I'm just going to use my calculator to calculate 385 divided by 5. Okay, and that gives me 5 times 77. Now we know 5 is a prime number. There's no more breaking 5 down because it would be 5 times 1, which tells us the same thing we have, 5. But 77 will break down again. Now, you know any double-digit number, 77, 55, 66, 44, 11 goes into that. So 77 is 7 times 11. Now, you keep breaking this down. 7, will it go down any further? No. So 7 is the end of that line. 11, will it go down any further? Well, no, because 11 is also a prime number. Now, I want you to compare what's missing. So one fraction at a time. So this 5 right here is right here. So the 5 we already have. But notice this denominator doesn't have a 7 or an 11. So I'm going to multiply by what's missing. I'm missing a 7 and I'm missing an 11. So on top, I'm also missing a 7 and I'm missing 11 because whatever I multiply in the denominator, I must also multiply in the numerator. Okay? Now separately, let's look at the number 7. When I compare it over here to what I want my denominator to be, there's the 7, so I don't need that. I'm missing a 5 and an 11. So I'm going to multiply this denominator by 5 and an 11, and if I do it in the denominator, I also have to do it in the numerator. All right, and then at the end, let's start over again. 11 compared to 5, 7, and 11. Well, there's the 11 right there. I'm not missing that at all. I'm missing the 5 and the 7. So what do? I multiply this denominator by what I'm missing, which is the 5 and the 7, and I also have to multiply it in the numerator. And now this just turns into a big multiplication problem. So 7 times 11 is 77 times 2. And feel free to use your calculator. 77 times 2 gives us 154. So that would give me 154. Now, we know 7 times 11 times 5 is 385. We already know that because there it is. 5 times 7 times 11, just in a different order. The second fraction, 5 times 11 is 55. 55 times 4 gives me 220, so the numerator is 220. The denominator is 5 times 11 times 7, which is still 385. And then the last fraction, 5 times 7 times 11, and the denominator is 385. The numerator, 5 times 7 is 35. 35 times 3 gives me 105, and I'm finished with that problem. Okay, so again, I think breaking these denominators down really is the best way to go. The quick trick on this problem wouldn't even work. Another homework problem says y over 2 plus 2 over 3. Now again, I didn't cover anything like that before. Let's take a look at it. Okay, y over 2 plus 2 over 3. Now I'm supposed to break down these denominators, right? So 2 doesn't break down anymore, 3 doesn't break down anymore. So that is broken down. You can even circle that to help you think about it. So what does 2 have that 3 doesn't have? Well, it doesn't have a 2, right? So I need to multiply this fraction over here by 2 in the bottom and 2 on top. Now, what does 2 have over here that this doesn't have? This doesn't have a 3. So I'm going to multiply by 3 on the bottom and 3 on the top. Okay? Now, when I simplify this, in the numerator, 3 times y, the best I can do is write that as 3y over 3 times 2 is 6, plus 2 times 2 over here is 4. Over 3 times 2 is 6. See, now we have a common denominator just using that same method. And even though we had algebra in this fraction, the method is exactly the same. So in the denominator, it's the common one is 6. In the numerator, these are not like terms. I can't add 3y and 4 together, so I have to leave it as 3y plus 4, and that's my final answer. And I've got one final problem here for you, and I think this is really the gist of this section. You could easily cross this way, 56 times 22, cross this way, 35 times 39. Do the calculation in the numerator. Denominator is going to be really big when I multiply 56 times 35. Let me just tell you how big. 56 times 35 would give you 1,960. But then you've got to reduce that to lowest terms. You're just talking about a big number nightmare, but it can be done. But let's slowly talk about the easier way. Really, you got negative 39 over 56. Remember, I'm writing this with some space in between it. 22 over 35. I want to break 56 down. Tell me any two numbers that multiply to be 56. Now, if the problem seems to be multiplication tables, we're going to have to practice those. You could even get an app on your phone where you practice multiplication tables, but it's so hard to learn algebra if you don't know them. And you need to know them. You need to know that 56 is 7 times 8. Okay? Now, does 7 break down anymore? 7 is prime. The only way to multiply to give 7 is 7 and 1, so I circle it. Does 8 break down anymore? Yeah, right? 2 times 4, or 4 times 2, it doesn't matter which way you write it. 2 is prime, but 4 even breaks down again into 2 times 2. So what is 56? Is 7 times 2 times 2 times 2. Now let's do the same thing for 35. Does 35 break down? I need you to know that 35 is 5 times 7. Does 5 break down anymore? 5 is prime. Does 7 break down anymore? 7 is prime. No other way to do it except 5 times 1, which doesn't help us, and 7 times 1. If you're using the number, when you break it down again, you're not really breaking it down. Now remember what we do next? Just multiply by what you're missing, okay? So when I look at 7 times 2 times 2 times 2, this one has the 7, right? But it doesn't have the 2, so I don't need to multiply it by 7. I need to multiply it by what it's missing, and it's missing the 5. You could even highlight or mark through the ones that match. You won't have to multiply by those. But this one is missing a 5, so I'm going to multiply by 5 over here, and it's going to be in both the numerator and the denominator. It's not 5 minus 39. Be careful, that's 5 times 39. What am I missing over here? Well, I'm missing the 2 times 2 times 2. So what am I going to do? I'm going to multiply by the 2 times 2 times 2. And if I do it in the denominator, I have to do it in the numerator as well. Then just use your calculator. What is 5 times 39? Okay, well, 5 times 39 is 195. Now it's going to be negative. So this is negative 195 over denominator. I'm doing 5 times 56. And that gives me 280. All right, now let's do this one. So I'm doing minus, kind of ignoring that for now. Numerator, 22 times 2 times 2 times 2. So that gives me 176. And in the denominator, it's 35. So I type in 35 times 2 times 2 times 2. And that gives me 280. Now, if I did this right, the denominator should match. And notice they do. Now, what do we do? So I've got negative 195. So I'm adding negative 195 to a negative 176. Or, you remember, you're thinking, why is she saying add? It's a subtraction problem. Remember, you can change subtraction to addition and change the sign of the next number. And since I'm adding two negatives together, the answer stays negative. So this is equal to, it's going to be negative, and then in my calculator I type in 195 plus 176. I get negative 371 divided by 280. Now the big question is, does that simplify it all? And this goes back to a previous section, and sometimes this is the hardest thing that you do, is determine whether 371 can be simplified. I know that they both don't divide by 2, right? 280 does because it ends in an even number. 371 doesn't. So then you got to check 3. Does 3 divide into 371? You can't just do it in your calculator. 371 divided by 3. And it gives me a decimal, so no. Then if you can't, no point checking 4, because if 2 doesn't go into both of them, neither does 4. 5 doesn't go into the top, right? 6 won't go because 2 and 3 don't go. You do need to check 7. 371 divided by 7. Oh, it goes into there. 280 also divides by 7. So you've got to check 7. Okay, so 371 divided by 7 is 53. So I'm dividing by 7. And and it's still negative. I got 53 in the numerator. And then I'm doing 280 divided by 7. And that gives me 40. And then you could check again for common factors. But 53 and 40, if you check for a few minutes, they don't have any common factors. And that's your final result. So yes, these problems can take a little while. Some of the homeworks are really big numbers, like this example right here. But if you just take it slowly, break down those denominators, multiply by what you're missing from the other side. Use your calculator to do the big multiplication stuff, and use your calculator to simplify the lowest terms. I hope this helps you out. Keep practicing. If you get stuck, please let me know, and we will keep working on this, okay? Have a great day.